Hello and welcome friends to 5 Minutes Engineering. In today's video, I am going to deliver the basic idea of what is a stack data structure with a highly relatable real life example. We all have kitchens in our home, and in that kitchen we have such kind of metal containers where we put the edible stuffs. Okay, so now which stuff should I put into that? Like, let's say biscuit packets. I like biscuits a lot, so I would just try to put up the biscuit packets of different brands, okay, into this respective metal container. Okay, so as I was mentioning about the biscuit packets, and here they are, 4 different brands of biscuit packets are with us, and now we have to put them up into this container. Okay, what would be the approach? Let's start with 1, 2, 3 and 4 like that. Okay, so what we'll do, we'll just put up this packet B1 and it will be settling down at the bottom of this container B1 like that. Okay, then we will go for B2 like this. Okay, then for the B3 and then the B4 like this. Okay, so all the packets are now in the container, and this itself structure is called as a stack. This itself structure is called as a stack. We do the same thing if talking technically. Okay, in the data structure named stack, we do the same thing. These B1, B2, B3, B4 are nothing but what? Data items, data elements, or stack items, stack elements that we put up into the stack like this, same way as I am putting the biscuit packets B1, B2, B3, B4 into the metal container. Okay, now one more thing that I would like to add to it is the process by which we were actually putting the biscuit packets into the container is called as push. Push means we were giving a push to the data item, okay, into the stack, and that is called as a push. Okay, like whenever we have to put something or insert something, some data item into the stack, so we have to use a push operation. Okay, and what is the other thing? Like, okay, we are giving up the data items, putting up, inserting into the stack, but let's say I have to take out one. I have to take out one of the data items. I have to take out, let's say, B4, the biscuit packet. Okay, then how would it be done? Simple, you have to use the pop operation. Now I am just in the beginning giving you the terms push and pop. In further coming videos, we are going to have a very detailed discussion about these two operations, but for now let's understand. Putting the things into the stack, we need push, and putting the things out of the stack, we need pop. Okay, so pop operation is performed and B4 will be coming outside the stack, and here it will no longer be visible into the stack. Simple as that. Okay, that's what the behavior is. One more thing to add up to that, the term comes top of the stack. Top of the stack. What does this mean? Top of the stack. What does this mean? Means you have to always observe the element, the data, which is at the top of your stack like this, B3. Remember one thing, whenever we are trying to perform this push operation, or whenever we are trying to put up something, insert some data item into the stack, it will be always on the top of the current top of stack. It will be always on the top of the current top of the stack data element. Means now currently the top of the stack element is B3, and I have to, let's say, again put up this B4 into the stack. So this B4, when it will be pushed into the stack, it will be sitting on the top of the current top of the stack data element, which is B3. Okay, simple enough. It will not be settling on the B2, it will not be settling on the top of B1. This B4 which we are pushing into the stack, it won't be settling on B2 or B1. No, why? Because they are not the current top of the stack data element. The current top of the stack was B3. Okay, so therefore on the top of that only the pushed data item will be settling down. That's the first thing related with the push. Now what about pop? Whenever you perform the pop operation, always the top of the stack element, always the top of the stack data element will be getting out of your stack, will always be getting out of your stack. Means let's say I am having this kind of a situation now. Okay, let's say my current top of the stack is B3, okay, and I perform a pop. when I simply perform a pop operation, B2 and B1 is not going to getting impacted. They will not go out of the stack. No. Why? Because they are not on the top of the stack. So they will not be popped up. The only element which will be popped up for that respective pop operation will be B3, and B3 will be going outside. B3 will be going outside, and you won't see B3 anymore in the stack itself. Okay, now the working or behavior of this stack data structure can be explained by just 4 words. Now what are those 4 words? They are pretty simple. Last in, first out. LIFO, we call it as a LIFO. Okay, what does that mean? Let's take an example, understand with this. Now this was the B1 which we pushed up first into the stack, and B4 is the data element or the biscuit packet that we pushed up the last into our container. Simple enough. Now it says about the last. It is saying about, describing about the situation of the last in, means the last one that was given in to the container, and it was nothing but B4. Now it's pretty easy to understand. Last in, that is a B4. Whatever is getting pushed into your stack last is getting out, popped up first. That's what you have to understand. Whatever data element is getting pushed last into the stack is getting out, popped out first from the stack. Okay, so B1 is not going to be getting out first. Why? Because it was first pushed into the stack. No, that's not how the stack is going to work. It will work as per this rule. It will work as per this rule, that is, the last element that is being pushed will be popped up first. Or you can say it in the other way also, like first in, last out. This way also you can describe the working or behavior of stack. Means what? The first one that we put up, that is B1, that is nothing but B1. It will be the last one to come out of the stack. The one that you have pushed into the stack first, it will be the last one to come out of the stack, popped out from the stack. So that is nothing but B1. You cannot just take B1 out first. No, you have to first of all pop B4, then B3, then B2, and at the last B1 would be there, which will be popped up. Why? Because this B1, biscuit packet 1, was the first to be pushed into the stack. So this was just the trailer of the movie named Stack Data Structure. There is more to come. There are more amazing facts and operations we would be exploring in the upcoming video regarding the stack data structure. If you found this video informative, do like this video, and most importantly share this video with all your friends. Thanks a lot, friends, for watching this video.